Okay, we are recording, ladies and gentlemen. Let's see. Number your problems. You got 40 problems on the final. Number them, please, so I can get to them easily. You'll have today at noon, tomorrow, and Friday till midnight. Same old, nothing new there. Be sure that you're showing work on the problems you need to show work on. If you're not 100% sure, then just show me something. I had a student email me yesterday saying, "What about this?" And it would have been very little to show. Or if it's one line, I'm not gonna be picky. But if it's 7 lines, I'm gonna be picky. It's like it's been for the 5 or 6 problems earlier, and like I stressed that it would be for test 4. So if work is required, show work. I don't want plugins. You can plug in all day long, but I also want to see the work that you do if you didn't have the plug-in aspect included. So show the work that you have to show if you didn't have a multiple choice problem. That might be the best advice. Show the work that you need to show, pretending like there isn't a multiple choice situation for you. Let's see. Yeah, okay, that's all good. If you want to number my problems at the top of each of your worksheet pages, you can do that right now. You can grab the scratch that you're going to use for the test and write number my problems at the top of each page. I'm fine with that. I don't want you to forget it. And it's fine if you write it on there. Okie doke. Last day of class. Let me get this thing situated. Let me focus it. And we will get started on the last half of this test. Anybody got anything on their mind before we get started? Okay, if you think of something, mention it. Let's see if that's too much light. Yeah, that'll do. Okay. Okay, graph the function by making a table of coordinates. It tells you to make a table of coordinates in this problem. It tells you that. So let's set this up, x and y. X is, well, what we would do here is I would expect you to look at f of x equals 5 to the x power. That's what the table would look like. Not this mess. We never did the x plus 2 in the exponent. We started with this and then we transformed. So same game. So 5 to the x power, we're going to use -2, -1, 0, 1, and 2. 5 to the -2 gives you 1 over 25. 5 to the -1 is 1 over 5. 5 to the 0 is 1. 5 and 25. If you forget these numbers, if you forget how to raise 5 to a negative power, use your calculator. Your calculator will tell you. Okay, let's graph this mess. Well, yeah, I want to graph this mess. So -2 right there, -1, 1/5, just barely above that, 0, 1, 1, 5, and then 2, 25. So this is going to do that sort of thing. And then we're going to transform it. Let's see what this tells us to do. The x plus 2 on the exponent, the 2 dealing with the x, that's telling you a horizontal shift, and it's always a liar. So we're going to go 2 to the left with this. That's what that tells us beside the x, like all transformations. And then the -2 is on the y-axis, and that tells the truth. So we'll go down 2. So I'm going to take the 0, 1 point. That's, to me, the easiest one, the belly button, and go 2 to the left, and then down 2, and it takes me right to there. And you can do it with all the points. And you can envision it. You can look at the multiple choices. Remember, on all multiple choices, every stinking one of them, you do not need to show any work. Sorry, not on all multiple choices, on all graphing. So on all XY graphing, you do not need to show work, even if it tells you to use table of coordinates. I've already told you all XY coordinate graphs I don't need to show work. So even though I just finished telling you you needed to show this, you don't. Not on the XY coordinates, just like Monday when I told you over and over and over and over and over Let's see, do we have any more graphing to go? Yeah, it looks like we got a little bit more graphing. So all of this, no work needs to be shown. So sorry about that misinformation there. And my guess is you pretty much know that that is any number to the x power is going to look like that. If you don't, you look at the multiple choice and you say, hey, that must look like that. Okay, let's look at number 28. There's the formula we're going to use. Can be used to determine the milligrams D of a certain drug in a patient's bloodstream H hours. H will stand for the hours after the drug has been given. How many milligrams to 2 decimals will be present after 11 hours? So they tell you that hours is 11. We'll plug in 11 right there. So we've got D of 11. We're going to find out what the milligrams are when we've got 11 hours later. How many milligrams are in the patient's bloodstream 11 hours later? Equals 9 times e to the negative 0.4 times 11. So it is absolutely just a plug-in. Make sure you understand how to work your calculator on this one. You can go straight from left to right. I'm going to go ahead and multiply these two. Negative 0.4 times 11 equals negative 4.4. Just going to have that. Then I'm going to start from the left-hand side. 9 times e. E is up here. I'm going to have to use a second function. There's e raised to the, and then I'm going to raise it to the negative 4.4. Close the parenthesis if you're in the mood to do that, and then equals 0.11049, etc. Remember, this is the number of milligrams that are still in the bloodstream after 11 hours, and they want it to 2 places, so it'll be 0.11. So D of 11 equals 0.11 to 2 decimal places. That's a coincidence that those match. That's just a coincidence. Okay, a little bit further into logs, start playing with them mathematically. This asks you to write it in its equivalent exponential form. There wouldn't be any work to show for this one. We're going to do that little circly thing. 6 to the x equals 216. Remember, the base is this the guy right here. That's the base in our exponential. The answer to a log is always the exponent. So this that's by itself will be the exponent, and then that other number goes over there. That's as far as you need to go with this. If you had to go further, I would just start playing around, 6 to the second, 6 to the third, but we don't. We're not solving this one. And you'll see that in the answers, that they're just giving you things like that. Okay, write the equation in its equivalent logarithmic form. We're going backwards. So we need an exponent. This doesn't have an exponent. Let's transform this. This will be 8 to the 1/3 equals 2. The cube root, remember the denominator is the index. Those are the same things. The denominator is the index in a radical to an exponent. Now we're ready to write the log problem. Log, base goes down here and the base is 8. Remember, the answer to a logarithmic is always the exponent, so we'll put 1/3 over there. And then the other number goes here. And that says, what do I have to raise 8 to have him become 2? 8 to the 1/3 power will be 2, making that circle. 8 to the 1/3 equals 2. 8 to the 1/3 equals 2. Same thing here. What do you have to raise 6 to become 216? That's 6 to the x power equals 216. So logs will make that circle around that you can translate into an exponential. Okay, one more domain problem. Find the domain of the logarithmic function. You cannot take the log of a 0 or negative number. Has to be a positive number sitting here. So 6 minus x has got to be greater than 0. That's the setup. Whatever you're trying to take the log of, you want it to be greater than 0. So this is the 4th problem, I think, that we've had asking about domain. Seems to be important. Okay, let's solve this by moving the 6 over. Negative x needs to be greater than 6. Divide by -1. And again, we're dividing by a negative with an inequality. So x, this will flip the inequality around. Remember, anytime you divide by a negative, So it becomes less than 6. And in this particular problem, I think that we are using the interval notation. So let me see, there's 6. If we're not, this is easier. So we're just doing more work than we need to on this problem. That's good. There it is. And we're not including 6 because that would give you a 0 here, 6 minus 6. You can't take the log of 0. You can try it in a calculator, it won't work. So this problem is negative infinity to 6, parentheses on both sides. Yes, it would. Thank you. Thank you. Appreciate that. Yeah, boy. Got to be thinking about what you're doing and not thinking about something else. Yeah, absolutely. 6 divided by negative 1 gives us negative 6. So it's still going to be, there we go, x is less than negative 6. Negative 6 goes that way, and there we go. Isn't it negative 6 when you move it over? No, it's not, because it's a positive here. So, oh, shoot, you're right. So, there I am, just talking my way through it. Let's start over on this problem. Let's start over, because it doesn't hurt to, and I've made a mess of it. Let's see, number 31. Yeah, so I wrote it down wrong to begin with. So we've got 6 minus x. It needs to be greater than 0. Anytime you're talking about a log, this piece has got to be not 0. It's got to be bigger than 0. So let's move the 6 over. Minus 6, we get negative x is less than negative 6. Then we're going to divide by negative 1 on both sides. So we get x is, ooh, got to change it, less than 6. There's 6. And we need to be shading to the left because that's what our arrow is doing. And this will not count. We won't include 6. So negative infinity to 6, parentheses. So in my original problem, I ended up getting it right originally because I screwed up twice. So there is a good work through of that problem without making brain fart mistakes. And that's all it is. I know how to do that problem. All of you know how to do that problem. Every one of you is going to get that one right, unless you make a brain fart mistake like I did. Okay, let's look at 32. Use properties of logs to expand this out. Okay, so let's see what we've got. We've got multiplication on top, x times y to the 4th. That means when we spread it out, we're going to have a plus sign between them. And then we're going to subtract the z squared. So we're going to have log base b of x plus, because they're multiplied up here, log base b of y to the 4th. Hang on to that for just a minute. We'll move that 4 in a second. Then minus log base b of z squared. So that takes care of 2 of the principles, the multiplication and the division. Multiplication turns into addition, division turns into subtraction. Then the power property moves that 4 to the front and that 2 to the front. So we end up with log base b of x plus 4 times log base b of y minus 2 times log base b of z. Okay, I'm going to write this on another piece of paper because it's even messier. So number 33, we write it down here first. We're going to expand this out in the same way we just expanded out the other one. Over x minus 2 squared. Okay. So what do we have? Log base a here. So we're going to do log base a. Is that an 8? I don't see an 8. That's a 3. X to the 4th, cube root of x plus 5 over x minus 2 squared. Okay, good. What is that? What is TH? Oh, thanks. Okay. I thought it was more. I thought it was more of this. Okay, we're good. So we got log base a of x to the 4th plus, because these are multiplied, log base a of the cube root of x plus 5. We'll mess with that in just a second. Minus log base a of x minus 2 squared. And again, we'll mess with that in a second. Okay, That took care of the product and the quotient principles. Now we're going to move that 4 to the front. We're going to move this 2 to the front. This is a little bit trickier because this is the same thing as x plus 5 to the 1/3. Cube root is the same as 1/3. The denominator is the index. So we'll move the 1/3 up to the front. So we'll have 4 times log base a of x plus, instead of cube root, it'll be 1/3 times log base a of x plus 5. You need parentheses because it's not just x. And don't worry, you're not going to have a multiple choice without parentheses and one with, and you're supposed to know which one it is. It's one of the ways that multiple choice makes it so much easier than you having to write it all out and show your answer, because it would be wrong without parentheses. Minus 2 times log base a of x minus 2. And that's that thing expanded out. Okay, let's go look at 34. Use properties of logs to condense. So we're doing the opposite. They have written it all out. We're going to make it look like this. So we've got a log base. We've got a natural log here and a natural log here. So we're using natural log. It does not require the little e. Wouldn't put that. Remember, this is a squared. We were going to return this product here up to the exponent. We're going to return it right there. And b9, and that's a minus. So this will be the natural log of a squared over b to the 9th, and you'll see parentheses around it because it's two things going on. So the exponent is in front. We're doing the reverse of what we did in 32 and 33. And then it's a subtraction problem, so it'll be a division problem. Okay, number 35, you've got parentheses here, so let's go attack the parentheses first. They're both log base 5s, so log base 5. We've got an r minus 9 minus r. That'll be division for r. There we go. And then all this is raised to the 1/2 power. The 1/2 power, you might see it like this, but you're much more likely to see it like this, r minus 9 over r. That sort of thing, where they'll take this denominator as the index. They'll change it from a 1/2 exponent into a square root of, and that's an r minus 9 right there. Okay. Let's look at this one. Number 36, we're going to start solving some of these logarithmic problems or solving them in exponentials, playing around with the idea. They're telling you to express the solution set in terms of natural logarithms. That's ln. Remember that? So let's see. We've got two different sides. We've got one simple side, one simple side. So let's slap natural logs on both. Natural log of 3 to the 9x equals natural log of 2.3. That allows us, see this x? What we're going to do is move the 9x to the front. That rule says you're going to move the exponent to the front. So we're going to have 9x times the natural log of 3 equals the natural log of 2.3. Now if we're trying to solve, we're trying to get x by itself. There's x. We want to divide. Everything here is multiplied times, so I'll divide by 9, and I'll divide by the natural log of 3. That means I'm going to have to do the same thing over here, divide by 9 and divide by the natural log of 3, and we're done. X equals natural log of 2.3 over 9 times the natural log of 3. How are you going to know what to do? Look at the answers. Look at the multiple choice answers, and they'll tell you what direction to go. They'll tell you when to stop. You're not having to look these numbers up and do all that division. You'll see that in the answers. And as I've told you a little bit before, this test is an easy test. People make good grades on the final. You have to prepare. I mean, there'll be a couple people that bomb it. But if you are coming into this with good grades, good solid understanding, and you practice on the review, and you're here, you'll be fine. You'll make the same grade as your average. You're not going to change your grade on the final. Almost nobody changes their grade on this final. There are other classes in the math department where grades change on the final, but college algebra just isn't one of them. This is a good test, I think. Okay, let's look at number 37. I'm going to take it over to here. 37 is 4 to the 3x plus 5 equals 1 over 256. This is a change of base problem. We want to get this base and this base to match. So you want to see, is 256 a multiple of 4? If you know, then you're good. But if you're not sure, play around. 4 humpy 6. Let's see. Oh, that's too much. So let's back it down. 4 raised to the 5th power. That's too big. 4 raised to the 4th power. There we go. Okay, so write yourself a note that 4 raised to the 4th power. You found it. You found how these two relate to each other. That's going to be important. So you're going to change both of these bases to 4s. This one is a 4. So 4 to the 3x plus 5, we're good. This number, though, we have to change to a 4. So we know that 1 over 4 to the 4th is the same thing as 256, but you got to get this up to the top. So 3x plus 5, and you know, if you ever want to move anything from the numerator to the denominator, make the exponent a negative. So they're equivalent. And if you're not sure about that, test it out. 4 raised to the negative 4 power equals, well, that's not helpful. So let's change it to a fraction to decimal, that f to d. We haven't used it a whole lot, but second f to d equals 1 over 256. So those are the same things. 4 to the negative 4 and 1 over 256 are the same. Now that the bases match, their exponents match. So let's do 3x plus 5 equals negative 4. And of course, from there, it's a simple solution. Minus 5 on both sides. And x equals negative 3. Let's see if they gave you any warning. They did not. To check it. No, it'll be good. It'll be good. That one you don't have to worry about. Okay, let's move to the next page. Doing some more logs. Solve the logarithmic. We're still solving. Be sure to reject any value that is not in the domain. That just means this has to be bigger than 0. That's the warning they're giving you. And so we'll check it. Let's see, give the exact answer. Exact answer means don't grab your calculator. Let it be in logarithmics. I'll show you as we go. Okay, let's look at 38. Got log base 2 of x plus 1 plus log base 2 of x minus 5 equals 4. These are both the same logs, so let's combine them like we were doing in the early 30s problems. So log base 2, this is addition, so that means this will be multiplication, x plus 1 times x minus 5. And strictly speaking, this should be bracketed, but not a big deal. You know, if you know what you're doing on your notes, that's fine. Equals 4. Okay. This is the logarithmic with one thing on both sides. Let's do the circle-y thing. So 2 to the 4th equals x plus 1 times x minus 5, and the rest is just super duper basic algebra. 2 to the 4th, 2, 4, 8, 16. Let's FOIL this out. X squared minus 5x on the outside plus 1x on the inside. So we get minus 4x and then minus 5. Let's get a 0 out of this. So minus 16 on both sides. And then you got to factor that. So we got x's. Signs need to be different. You're looking for what two numbers multiply to give you 21 that are 4 apart, and that's 3 and 7. And thank you, Chloe, for showing me how to do a different way that just makes sense, I think, to more students rather than put the big number with that sign, is to say, how are we going to get negative 4 out of this mess? There have to be a negative 7 and a positive 3. So let's put the 7 there and the 3 there. So we got x equals negative 3 and x equals positive 7. Remember, they warned you, be sure to reject any value. I don't know that that warning is going to be on the final, but here's the way to protect yourself from that. One of the answers will look like that. One of the answers will look like that. You know, they'll start eliminating some of the answers, and your brain needs to say, I got these two. Why are they offering me having rejected one of the answers? And your brain says, oh, I got to check answers. So let's check -3. -3 plus 1 gives you a -2. You can't take the log of a negative answer. So that's done. 7 plus 1 is 8. Good. That's a positive number. 7 minus 5. Good. That's a positive answer. So 7 would be the answer there. You cannot take the log. This piece cannot be negative. It's a super easy check. It's just one you've got to remember how to do. And that's the problem. You've got to remember it. Lots of stuff stuffed in your brain. If you are going past this, if you're a STEM major, then you got to keep it in your brain through pre-calc. If this is your last math class, you dump it at the door. Grab a donut and dump it at the door on your way out of the test. Yes. Look at all you late afternoon people here in the early morning class. Crazy. You're welcome. Okay, let's see. We've got another couple. We got 2 plus 2 times the natural log of x equals 7. Doing that kind of a problem. Let's see. We're going to have to solve for x. Let's get rid of this 2 first. We want to have this piece by itself. So -2 minus 2. 2 times the natural log of x equals 5. We're trying to get to x here. Trying to get to x, so let's shed the 2 now. Let's divide by 2. So we've got the natural log of x equals 5 over 2. We want to get x by itself. We can do that by remembering that you've got an e down there. Remember, natural log has a base of e. Let's do that. So we get e to the 5/2 equals x, and you're done. That's all they wanted there. They said, give the exact answer, which means don't go after your calculator and raise e to the 5/2, because then you're going to get a number you'll have to round. And no worries. You don't have to worry about screwing that up. Look at the answers as you go. They will not have a little number, you know, they are not going to give you e to the 5/2 and give you, let's see what that is, e raised to the 5, ABC2, 12.18. So they're not going to give you this and a 12.18, and you're supposed to have read the instructions carefully enough to know they wanted you to stop here. Those are the kinds of answers they're going to have for you. Like they'll have e to the 2/5 and e to the 5/2 and stuff like that. So you'll know when to stop. It's not going to be an issue. Okay, let's look at number 40. So we've got common log of 2 plus x minus common log of x minus 2 equals common log of 3. Okay, we're going to be able to take off the logs if we can get 1 log on this side. We got it. We need 1 log on this side. So this says minus. That means we're combining them through division. The subtraction, we'll use the quotient property to divide. Now we've got a log equal to a log. We can get rid of the log words. So we have 2 plus x over x minus 2 equals 3. And let's go ahead and solve that. We got to get rid of the denominator first. So I'm going to multiply this side times x minus 2, and that'll cancel out. X minus 2 in the numerator will cancel with x minus 2 in the denominator. Whatever I do on one side, I've got to do on both sides, and this will be distribution. So we get 2 plus x equals 3x minus 6. And then the rest is just a little bit of algebra. I'm going to move the x's over to the right. So I get 2 equals 2x minus 6. Because I brought the x's to the right, I've got to bring the other numbers, the numbers, to the left. So x equals 4. Let's make sure that's legal. 2 plus 4 is 6. That's a positive number. It's cool. 4 minus 2, that's a positive number. That's 2. It's a positive number. And there is no variable over here. So this is a good answer. That'll work. Okay. Now we shift into what we did in the last test. The matrices, the sequences, series, that kind of thing. Give the order of the matrix and then identify that element. So the order, remember, it's always going to be rows by columns. So we have 2 rows by 1, 2, 3, 4 columns. So it's a 2 by 4 matrix. And they're asking you to find the element that is in the, again, this is row by column. They're asking you to find the element that's in row 1, column 2. That's what 1, 2 tells you. Find the element that's in row 1, column 2. So the first row is the top row. The second column is this one. So 9 is what they're looking for. A sub 1, 2 is a 9. Okay, solve the problem. We're doing A minus 2B. So I'm going to do A, and I'm going to do 2B, and I'm going to minus them. A is 1, negative 3, 2, minus. And then I got to do 2B. 2 times negative 1, 2 times 3, 2 times negative 2. And now I am just 1 minus negative 2. 1 minus negative 2 is 3. Negative 3 minus 6 is negative 9. And 2 minus negative 4 is 6. And there's the answer, A minus 2B. Okay, number 43, we're solving the matrix for x. So I'm going to first solve this for x. Got B minus x equals 3a, and I want to get x by himself. So I'm going to start by subtracting b on both sides. So we get negative x equals 3a minus b. I've got to divide by negative 1. And so that gives me x equals negative 3a plus b. Just means change the signs of every one of these up here. So positive divided by a negative gives you a negative 3a. Negative divided by a negative gives you a positive. If you prefer to do b minus 3a, that's fine. I'm going to do it this way just because I don't want to do, got to pick a way. Can't do it every way. So let's look at negative 3a plus b. So first thing I want is negative 3a. So I'm going to multiply the A matrix right here. I'm going to multiply it times negative 3. So 1 times negative 3 is negative 3. 4 times negative 3, 0. Negative 2 times negative 3. 6 times negative 3. And negative 6 times negative 3. Then it's a plus. So I want to add to that b. I'm just going to copy b down. Okay. And then the answer, negative 3 plus 8, negative 12 plus negative 6, and just continue on, adding them up. And there you go. Okay, let's look at 44. 44, we have got A is negative 1, 3, 1, 6. Looking at your scratch paper, I see that I was not showing enough work. I see you guys showing a step that I was not putting in, so I will amend what I do when I show it to you, because I guess if you're showing it, you're needing it. So what we're asked to do here is to find AB if possible. So let's see if we can first find it. A matrix is 2 rows by 2 columns. So A is a 2 by 2. B is a 2 by 3, 2 rows by 3 columns. In order to multiply the two in that way, A, B, these have to match, and they do, and this will be our answer matrix. That's the size of it. It'll be a 2 by 3. So it'll be a 2 rows by 3 columns. It's going to look like that. And I saw you guys putting answer marks there. I think that's excellent. I think otherwise you can just go, stir crazy and cross-eyed trying to do it. Okay, so this position is row 1, column 1. So I'm going to multiply row 1 times column 1. Row 1 of A times column 1 of B. And so I've got -1 times 0, and then scoot over on the row, scoot down on the column, plus 3 times 1. This is the step I saw so many of you write that I didn't. That's 0, that's 3, so this is 3. Next guy, this is row 1, column 2. So I'm going to be grabbing row 1 again and column 2. So that's -1 times -2, plus scoot over and scoot down, 3 times -3. So that gives us a 2 and a -9. So that's a -7 there. Next one, this is row 1, column 3. So I'm going to be using row 1 and column 3. That's -1 times 4, and then scoot over and down, plus 3 times 2. So -4 plus 6 gives us a 2. I know at this point you might be able to pick out from the multiple choice which one is correct. Keep going. I want to see what you're doing here. I want to see that you get it. Even if at this point you can tell which one is correct, show your work, show your work, show your work. Okay, row 2, column 1 is the number that will go there. So that'll be row 2 and column 1. Row 2 is the bottom one, column 1 is this guy. So 1 times 0 plus scoot over, scoot down, 6 times 1. That's gone, so we get a 6. This is row 2, column 2. So 1, 6, and -2, -3. So it'll be 1 times -2 plus shift, 6 times -3. So we get a -2 plus -18, that's -20. And then finally, we're doing row 2, column 3. Row 2, column 3. So 1 times 4 plus shift, 6 times 2. So 4 plus 12 is 16. And there's AB. BA is something completely different. I know it doesn't ask you for BA, but if it did. B is 2 by 3. A is a 2 by 2. In order to play the game, those have to match. They don't. So this cannot be done. You cannot multiply B times A. That's not possible in the world of matrices. Okay, let's look at, another thing I discovered. I'm working on Canvas, getting my classes ready for Canvas and just playing in my sandbox. 2 things I've discovered about Canvas. Well, number 1, I've been moving my recordings for these classes out of BBCU and into YouTube so I can transfer them to Canvas. And what I have discovered is that I say okay all the time. And for that, I apologize. I had my freshman year in college, I went to a community college in Lake Jackson called Brazosport College. And I took a class with my best friend. My history professor said, for all intents and purposes, he must have said that. I mean, we started keeping track. We had a little count going. Each one of us would see if we got the same count at the end of the class. And we should have gotten kicked out of that class. We were laughing so hard most of the time. We were, well, at least you know it when you're young. It's taken me this long to figure out that I say okay just about every transition. So if you're sick to death of hearing that, I apologize. Okay, oh, the second thing I learned about Canvas, this is so cool. In Canvas, you have a what if column in your grades column. So you can go in, hit the grades column, and then play around. You can put in grades for yourself. What if I make a 90 on the next test? I know, makes you want to not graduate, Chloe. Oh, but all Canvas has that. So if you go to a school with Canvas, you'll be there too. It's such a cool tool. You can see what kind of difference. Canvas is our new Blackboard, Rebecca. We'll stop using Blackboard in the fall. The teacher will miss you, Amanda. And who? Somebody else. Adrian, maybe? No, Adrian, we were talking about something else. No, I think we were. Yeah. Is there an app for Canvas? I don't know. I do not know. Oh, you'll get used to Canvas. Canvas is kind of sweeter, Ashish. It's it's new, and change is always not as much fun as not change. But Canvas has a what if column in the grades. You can play with it. It goes away. It doesn't change your grades. You can't get in there and break in and change your grades, unfortunately. But I love that what if. That to me is the number one thing I would like Canvas over Blackboard. Okay, let's see. No, it is not, because they're not using it yet. They won't be using it until fall. Although, God, this is so, whatted up there. If you are in summer 1, you are Blackboard. It's going to be a mixture in summer 2. If you have a TCC plus, I think if you're TCC plus, you are still Blackboard, but if you are not TCC plus in summer 2, you are Canvas, or it could be the other way. I'm not teaching summer, so I don't know. But TCC plus people will either be using Canvas or Blackboard, and the other one will be using the other one. Then in fall, we're all together. All classes in fall are using Canvas. And you will have access to that, 7 days before class starts. It's a simpler system for you. TCC is forcing all teachers to have the same left-hand edge of buttons. You can't change the order. You can't take them out. It's a simple system. You'll get used to it very quickly. People who've done both, UTA uses Canvas, and people who've done both, I think generally prefer Canvas over Blackboard. So it's not a stressor. It's just not. I'd stress more over the new system of WebAdvisor, although that's a better system to have all that stuff in one place is really cool for y'all. It's just changed. You know how change is. Okay, determinant. We're going to multiply those two guys diagonally across. So clear that. Let's see, we've got 1/6, 1 ABC 6 times 11 ABC 5 equals, it gives us 11/30. Then minus whatever we get this away. So this away is -7 ABC 9 times 1 ABC 4. That gives us a -736. That's going to be plus a plus. So we're going to do 11 ABC 30 plus 7 ABC 36 and get 101 over 180 out of that. I could handle not seeing your work on that. I don't need to see your work on the determinant problem, especially if they're whole numbers. I know many of you can do that in your head. I don't need to see this. So, and if in doubt, throw me a bone, give me something if you're not sure. Write the first 4 terms of the sequence whose general term is given. Okay, let's get a new and fresh piece of paper. And anybody who wants to know what they need on the final, to keep their B, to pass, to keep an A, to make an A, just shoot me an email and I'll get back to you. Let's see, A sub n equals 4 times 2n minus 1. We're looking for the first 4 terms. A sub 1 equals 4 times 2 times n. N is a 1 minus 1. So we're getting 4 times 2 times 1 is 2. 2 minus 1 is 1, so we're getting 4. So a sub 1 is 4. A sub 2 will be 4 times 2 times n, that's 2 times 2. So that's 4 minus 1. So we get 4 times 3, we get 12. A sub 3, same routine. 4 times 2 times n is 3. So that's a 6. So that'll be 4 times 5, it's 20. Notice the pattern. We're adding 8 each time. That's what happens in arithmetic sequences. You're adding each time. So we know the next one would be 28, but let's go ahead and do this. 2 times n is 4. So that's an 8. So it's 4 times 7, 28. And that's as far as they wanted us to go. Number 47 is asking you to come up with the sum. Giving you that sigma letter. I equals 1. That means we're going to start with our first variable being a 1. Our last variable will be a 5. And the formula we're plugging in is I minus 10. Okay, I think this was the one you had on your test, but you went different on that. So where I equals 1, where I equals 2, 3, 4, and 5, then I'm doing 1 minus 10, 2 minus 10, 3 minus 10, 4 minus 10, and 5 minus 10. And then this sigma tells me to add up these numbers. That's your job, is to add those numbers up. So 11, 18, 26, looks like negative 35 there is the answer. Negative 35. Okay. Oh, sorry. Now that I know I say it, I got to stop saying it. Let's look at number 48. 48 says, write the first 4 terms of the sequence whose general term is given. This is difficult to read. I had to go back and figure out what on earth they were doing here. This is a sub n equals negative 3 times n plus 2 factorial. Okay, and the factorial only applies to the n plus 2, not to the negative 3. You're going to do n plus 2 because that's parenthesis. And then this is kind of like an exponent. You'll do it next. Then we'll do the multiplication. So we'll have a sub 1 equals negative 3 times 1 plus 2 factorial. That's negative 3 times 3 factorial. And 3 factorial is 3 times 2 times 1. So that's 6. So we get negative 18. A sub 2 will be negative 3 times n is a 2, 2 plus 2 factorial, that's 4 factorial. 4 factorial is 4 times 3 times 2 times 1, so that is 4 times 3 is 12, 24. So we're getting negative 3 times 24, which is negative 72. A sub 3, same routine. Remember, I promised you the end of this class was easy. 3 plus 2 factorial, that's 5 factorial. 5 times 4 times 3 times 2 times 1. And that equals positive 120. And then times negative 3 is negative 360. And finally, the last one, negative 3 times n plus 2 factorial. So 6 factorial will just be this times 6. So that's 720. And then 720 times negative 3 is negative 2160. Okay, number 49 says write the first 5 terms of the arithmetic sequence. They tell you a sub 1 is 13 and the common difference is negative 3. You'll have another one for geometric sequence right after that. So 49 has a sub 1 is 13 and the common difference is negative 3. You need to know that that means to subtract 3 each time. So a sub 1 is 13. They've given you that. They're asking you for the first 5 terms. So we'll get the first 5 terms going here. Each time we're going to subtract 3. So 13 minus 3 will give us 10. 10 minus 3 will give us 7. 7 minus 3 gives us 4. And 4 minus 3 gives us 1. And of course, we could go on and on forever subtracting 3, but they only asked for the first 5 terms. 50 is similar to that, except that, there they spot you the first one, and they tell you the common ratio is 4. So you've got the first one. Common ratio means you're multiplying. So 5 times 4 is 20. We're just going to multiply times 20, or sorry, times 4 times the common ratio each time. They want the first 5 here also. So 20 times 4, 80 times 4, and then 320 times 4. So there's the first 5 terms. The first one is given to you. That's why it's got a 1 there. First one given to you. Okay, last page, last test, last day. Use the graph to determine the function's domain and range. So domain, remember, is what of the x-axis you're using up. This is a point here. This is the last point it's using up on the x-axis. It doesn't go further than 6. So we know we're going to end at 6. But let's see where we start on the left-hand side. This arrow goes forever. So we're starting at negative infinity. We're finishing at 6. And because that's a filled-in circle, you know you're including 6. The range, what are you using of the y-axis? We start at the bottom. Always start on the negative numbers for both domain and range. Start at the negative, so we started way down there. That'll take us all the way down there. And what's the highest on the y-axis that you reach? Be careful, it's not 3. It goes higher than that. The highest point on the y-axis is a 4, and it's included. And then I threw in this freebie because I've looked at the final. Find f of negative 3. Find f of negative 3. So let's do that. On this graph, it's telling you the x value. You're supposed to find the y value. So I'm going to go to the x-axis till I come to negative 3. It's right there. And then I'm going to go up or down to locate my graph, to locate my function. I got to go down because the graph is down here. So I go down to here on the negative 3 line, and it's right there at negative 4. So this is giving you the x, you give it the y. So f of negative 3, when you plug in negative 3 in the x, what do you get for y? You get negative 4. So you'll have a problem like this on your final. See, number 52. The graph of the function f is given. Use the graph to answer the question. Find the numbers, if any, at which f has a relative minimum. Okay, that is asking for the x values here. What are the relative minima? That's asking you for the y value. So find the numbers at which it has a relative minimum. Well, that's at negative 1 and 1. That's the lowest place this gets. So at negative 1 and 1, we have got a minimum. Now, how low does this go? Where is it? What is it? It's at 0. That's as low on the that's as low on the y-axis as it goes. Think about this like a roller coaster. So where you get to the lowest on the roller coaster happens right at negative 1 and 1. How low do you go? You go to right there. That's as low as your roller coaster goes. It goes just to 0. And then let's look at an increasing interval. This interval increases from there to there. That's the only part that increases. And you name values on the x to name that. So this begins at 0. And then watch out. They're doing this. They're jumping by 3s. So that's 3. This is supposed to be 5. Don't worry. There's not a difficult x-axis to read on your final. So they want you to know that that's a 5. Be careful. It isn't increasing at 0. It's just sitting still at 0. It doesn't start increasing till it takes off. So 0 needs to be parenthesized, because you're not increasing then. Same thing, once you get up here to 5, you've stopped increasing. You're not increasing at 5, and in fact, you're turning back around. So 5 also needs to be parenthesized. And I think that Ms. Thurlow on the answers for this pointed that out. Be careful about that. That needs to be, on increasing and decreasing, you are never going to include the number itself, because once you get there, you stop increasing, or you haven't begun increasing at that point. Last problem, get a tissue, wipe, dab the little tear at the corner of your eye. You are done. Those of you going on to pre-cal, good luck. Keep doing what you're doing. Those of you who are done with math, say do a little happy dance if that makes you happy. Let's see, let's get this last one done. Determine whether the given quadratic function has a minimum or a maximum value, and then find the coordinates of the minimum or maximum value. Okay, we've got an x squared, so you know that's a parabola. Oh, but it's got a negative in front of it, so you know it's doing that kind of thing. So it is not going to have a minimum, it is going to have a maximum. That's not what it looks like. It looks like that. We're supposed to find that point. So we're going to find the tallest, the highest, the maximum value this parabola reaches. The way to find the coordinates is to do that negative b over 2a thing. So let's see, negative b is a negative 2 already, over 2 times a is a negative 1. That's a negative right there. So we get 2 over negative 2, we get a negative 1. So that point is a negative 1 something. I don't know what the y value is. The way to get the y value is to plug in the negative 1 into this equation. So we got a minus, then x is a negative 1, then 2, negative 1, minus 4. So, wow, what a mess. What an easy place to mess up. You got to do exponents first. Negative 1 squared gives you a 1. So this becomes a negative 1. Negative 2 times negative 1 is plus 2. And then there's a minus 4. So we get 1 minus 4. We get negative 3. So that point is at negative 1, negative 3. So something like that. Negative 1, negative 3 right there is where that parabola sits. Okay, I think we are done. Hang out if you've got a question. Otherwise, go study. Hang on a second. Number your problems on your test. 40 problems, 2.5 points each. Yeah, 40 problems, Lee. 2.5 points each. You've got, if you know about what you need to make, or you know exactly what you need to make, each problem is worth 2.5 points, so gauge that. Don't kill yourself over one problem. Come back to it later. You got 2.5 hours to take the test. I know that stress, I get it. I hear your stress, some of you, but know that I've never had a student take too much time on the final for this class, not for 0362. 0362, I had people panicking, but not college algebra. This is not a difficult final. This is not a time-consuming final. So do your best. I will be upstairs in the NTAB in the fall, upstairs in the adjunct office in the afternoons on Monday and Wednesday. If you want to come by, I would love to see you. Otherwise, stay safe and healthy and have a good summer and do well on your final. I will see you around.